Yeah. I won't use the laser pointer then. All right, kia ora koutou everybody. My name is Genevieve Early, and this summer I have been working with my supervisors, Doctors Ian Dickey and John Perker, on a question about can we use native pathogenic Armillaria fungi to improve the management of invasive wilding pines. So as the situation stands, you've probably all heard of wilding pines. So there's a pine species, as you can tell, that are generally escaping from farmland and forestry. They are encroaching quite typically upon sort of grassy situations that you see here, and New Zealand is obsessed with eradicating them, but our management at the moment is not particularly effective, frankly. It is expensive and labour intensive using herbicides and manual removal, and the big problem is that it requires follow-up management over the course of years or decades to prove effective, which is often not being done. So we have a question about the native fungi Armillaria, which is pathogenic. It is a major pest in pine forestry, or it has been traditionally. It's not as bad now. It requires wood to survive, and it decays dead wood as well as reducing the growth of live wood and occasionally killing trees. So our question here is, can we use the native fungi, re-establish it in these sites and use it in conjunction with other management techniques to advance decay and reduce the incidence of seedlings growing? So to do this, we went out and collected wood, which you'll see in this beautiful glamour shot on the left. And on the right is the site that we went to in Craigieburn. Now this is considered to be a managed site. As you can see, there are blatantly still live trees there of adult reproductive age. There are also seedlings coming up through the grass that are continuing to establish themselves. So this is what we call the re-invasion of a managed site. So to do this, we, number one, collected the wood that you saw. We took the wood back to Canterbury. We assessed the ages of the wood. So we had everything from live trees that I felled all the way down to quite decayed dead wood that has been felled and sitting on the site for several years. So we also wanted to know what the existing fungal community is like at an invaded managed site, to look further at the ecology, as well as possibly is Armillaria already present there but not doing much. So I don't have results yet because the DNA sequences are not back, but I have isolated and cultured fungi from the pine wood before we sterilised it, and that will be reported later. So the main body of the experiment here is measuring the growth of 5 isolates of Armillaria that we obtained from Manaaki whenua on these sort of wedges of wood that we cut from the collected wood. 3 of the isolates are one species, Armillaria novae zelandii, which is considered the major pathogen amongst the group that you find in New Zealand, and there are 2 other species, Armillaria Aotearoa and Armillaria limonea. So this is the growth that we've got after 8 weeks. You can see that this is Armillaria novae zelandii in this question. We've got quite a dense little mycelial colony going on there. It's actually grown really well over the course of 8 weeks. And here are our results so far. So the main result and takeaway point from this is unexpected to me, that the live and the fresh wood provides by far the best source for the fungi to inoculate on. I was not expecting this because I thought that the freshest and most alive wood would be the most full of defence compounds, terpenes, all sorts of things to try and discourage these fungi from settling, but they overwhelmingly grow better on those. Out of the isolates that we've tested, the 3 from Armillaria novae zelandii are proving like far and away quite better colonisers on fresh and live wood than the other 2 species. But I don't have the final data back from that as well, and I suspect Armillaria Aotearoa might prove a surprise finalist. But the main takeaway point from this is that, well, I didn't quite expect this result. This suggests to me that this project is actually quite feasible. And from a practical standpoint, if we are able to go in during or after other methods of control and potentially inoculate a site, that is quite cost effective and quite practical to do it all in one fell swoop rather than having to wait 6 months or a year to reach an optimum decay point and then go in there spreading our fungi around. Cool. Any questions?
Questions for Genevieve?
Yes.
Which pine species were you looking at?
We have not determined it down to species level because of the decay state of a lot of the wood that we were collecting. We were unable to identify it to which species of pine it is. I suspect most of it is contorta, but we've just left it as wilding pines for the purpose of this experiment. Yes?
For your growth of the fungus,
Yes.
how dependent is our moisture content?
I've wondered if that's come into it. We've tried to control for that by, for all of the jars that I've put together, we did add in some extra distilled water at the beginning of the experiment to try and provide enough humidity in cases where the wood wouldn't be as wet, I guess. We also soaked all of the chunks of wood in water before inoculating them, so they theoretically all should be sort of reasonably similar moisture levels. But as far as environmentally, I believe that will be probably part of a determining factor in which sites may or may not be suitable for inoculation. Like if you've got an area that's just dead dry all year, fungi is probably not going to take.
Thank you very much.
Cool. Thank you.